Alright, so today's topic in this video will be laws of exponents and how we are going to use them to solve all of these problems that contain exponents. Now, the first problem, you might be thinking, well, a negative plus a negative equals a positive, right? So we'll just have this and then we'll get this. Well, although your answer might be correct, there's a special law that you have to know in order to fully understand this problem. So notice that we have a negative out here. This negative represents an invisible 1. So in reality, you have a negative 1 out here. And then you have your negative 1 in parentheses raised to the 11th power. Another fact that you need to know to completely understand this problem is that there is an invisible exponent on the negative 1, which is 1. And that's true for any number. Let's say you have a 5. It has an invisible exponent of 1. And it really doesn't affect the number itself. It doesn't affect 5 in any way because it's just 1. But a good thing to know is that it's always there in an imaginary way. So for this problem, we do care that there's an invisible 1 exponent here, because what we'll have to do is add these exponents. Now, you should know that one of the most important laws of exponents is that you can only add your exponents if there's a like base. Now, as you can see in this problem, we do have a like base, so we'll be able to add our exponents. In the end, we'll have 1 plus 11, and our final answer should be negative 1 to the power of 12. If we do this math, we'll be able to see that our answer is definitely positive 1. You could have gotten the correct answer if you would have just looked at the problem right here. Probably would have changed it to a positive, but you do need to know these facts in order to fully comprehend the laws of exponents and do the rest of the problems correctly as well. Alright, so in this next problem, we see kind of the same idea, right? We have two exponents and we have to add them. But in order to add them, we always need to make sure that we have a like base. Now, is that the case in this problem? Do we have a like base? Well, let's think about this. We have a negative 2 and we have a 2. Well, because of the negative sign, we don't have the exact same base. So we're going to kind of have to switch up this problem a little bit by putting the negative 1 on the outside and putting our 2's with our exponents in parentheses. Now that our problem looks like this, we have like bases, and we are able to add our exponents and keep our base. And that will look like this. Now, you just have to do some math. What is 2 to the power of 5? 2 to the power of 5 is 32. Because we still have our negative sign on the outside of 32, our final answer is going to be negative 32. Alright, lastly, I just wanted to take a look at a problem where there is no like base, and it's not an easy fix like the previous problem. On this problem, we have to take into consideration the exponent that is the power of 0. When anything is raised to the power of 0, it automatically equals 1. So here we just have 1 times 3 to the negative 3rd power. Now, when we have a negative exponent, we want to write this picture as its reciprocal, and that will look like this. So we have 1 over 3 to the 3rd power. The last step is just to do some math. What is 3 to the 3rd power? It is 27. So our final answer will be 1 over 27. Alright, that's it for today. Hope you found this stuff helpful.